All right, so we're looking at finding the sum of a geometric sequence. The sum of a geometric sequence is called a geometric series. So we're looking at geometric series. So here we have the sum of n terms in a geometric sequence. So the first term in the sequence is u1. How can we write the second terms in terms of u1 and r?
U are u times u1 times r.
u1 times r. How can we write the third term in terms of u1 and r?
u3 times
2 times
In terms of u1 and r.
So what's r?
u1 times r squared.
u1 times r squared. u1 times r squared. What is r?
The constants. It's the ratio.
It's the what?
Ratio.
The rate?
The common ratio.
The common ratio. You need to know the terminology. You need to know what a series is. You need to know what a common ratio is. So, how can we calculate the penultimate term?
The penultimate term would be.
Let's have somebody other than you, Christian.
You mean the last one?
The penultimate one.
Second one. U times r.
Is it u?
U1.
u1 times r. Should we do the ultimate one first?
Yeah.
We've memorized this formula. Hopefully, what is the ultimate term?
u1.
But how can we turn in terms of u1 and r? What's the formula? Not yet. Give them a minute.
R to the power of n minus 1.
Yeah, this is u1 times r to the power of n minus 1. So the penultimate term would be what?
N minus 2.
N minus 2. You see how it's easier working backwards a little bit like that?
Yeah.
All right, so we got all our terms in our sequence. What we're going to do now is we're going to take that sequence and multiply it by r. What will happen to the first term?
u1r. It becomes u100.
And what is that?
That's the second term.
Oh, it moves across, doesn't it, like this? And if we take the second term and multiply it by r, what does that do?
That becomes the third term.
It becomes the third term.
It makes sense.
So the pre-penultimate one would fall into this place. The penultimate one would move across and line up with the ultimate one. And then we get one more term over here.
Yeah.
Notice how the whole sequence moves across by 1.
Interesting.
Do we see this?
Yes. Sir, yes, sir.
Now, the reason I've done this, because this isn't, we don't know how many terms are in this sequence. But now, if I subtract the first equation from the second equation, most of them are going to cancel out completely.
Except for u1 and u are to the u times r to the power of n, right?
Yeah. So we'll get u1. So there's a 1 missing here. We'll get this term, which is this one here at the end, and we'll subtract this term from it. That's all that's left. Everything else in that, we don't know how many is in that subsequence, disappeared, and we know exactly how many is left. There's 2 terms left. And over here, we'll get SNR minus SN. Now, on the left-hand side, if we factor out Sn, what are we left with? What's going to go inside the bracket?
Wait, what's your question again?
We're going to factor out Sn from the left-hand side. What will be left?
R.
SNR minus how much? If we factor Sn out of both terms, it should be 2 terms inside the bracket.
u1. Wait, no.
What do we multiply Sn by to get minus Sn? Negative 1.
Oh.
So on the right-hand side, what should we factor out?
u1.
u1.
Okay.
Why are we factoring out u1?
Because
It's the one that's
Yeah, it's one.
It's common. It's a common factor.
R in there.
We get Rn
-1.
minus 1.
Okay, so now,
We want Sn on its own. We want Sn on its own.
so we take out R-1.
Take out R minus 1. What do we do with it?
We move to the other side.
How? We want mathematical operation.
Oh, I don't know the name for it, but I mean, you would take it out from both sides.
You
Uh,
divide both sides
Divide.
by R.
Oh, we just copied it.
So we divide
I
both.
did know the name for it.
Division. If you divide, it comes from the fact that R minus 1 divided by R minus 1 is 1. Anything divided by itself is 1. So you can move these across, so to speak, by dividing by them. You're cancelling it down to a 1, and 1's disappear in these type of expressions. But it means that we get one down here, which is the formula.
Yo!
Whoa.
That was cool. That was a cool way to end it. Okay, that makes sense.
So this is the formula for finding a geometric series. This is how we do the proof. There's two forms of it, but it's the same formula. Just notice inside the brackets they move the other way. And you do this by multiplying top and bottom by -1. So -1 over -1 is still just 1.
So, sir, would we get a question like this? Like,
No.
quoting the formula?
No.
Just to understand, right?
Yeah, it's just for understanding, a conceptual understanding where it's coming. AA, right, you can get this, but even the SL kids might not do it, it'd be higher level. But yeah, I think it's easy to follow, it's interesting to see. The reason I go through these type of proofs is you'll get to a course in a couple of years' time where you have to do this. So I think it's good for although I'm not going to be testing on you, I expose you to this type of proof because it takes a while and then it'll put you in better stead in maybe 2 years' time.
So it's also easy to understand if you know where the formula comes from. Like I remember I was really struggling with circles until I looked up how the pi worked.
Yeah.
And then it started to make
Yeah,
sense.
your university professor is going to want to prove the formulas, and you're going to need to be able to follow what he's saying, and he'll go faster than I did. So that's why I do it. So there's the sum. So that you can see it in 3 different forms here using sigma notation and then the 2 forms. We can use either. So have a go at using it now.
Okay. Formula time.
We hand out the formula booklets, and I'll pause the video. Okay, we're back. So we need to identify what the first term in the sequence is. What is the first term? 7. We need to find how many terms are in the series. 8. We're adding 8 terms, so n is equal to 8. And lastly, we need to find r. We do this by taking u2, dividing it by u1, which gives us 28 over 7, which gives us 4. So now we can find the sum of 8 terms. Notice the use of the index here as 8, so it's the sum of 8 terms. We need 7, bracket 4 to the 8 minus 1 over 4 minus 1. And this gives us a big number. Is that 15,000? Is it?
152,950.
152,000?
950.
15 or 50?
15.
915.
Okay. Have a go now at this question. So, I shall pause the video on this one.
Bye, Sophie.
Okay, so let's have a look at this one here. We've got Kenzo Starks Bright Academy. The school fees are 2.5 million yen. The fee increases by 2% each year. Kenzo attends the school for 6 years. A. Write down the value of R. So what's R going to be?
It's going to be
1.02. B. So we need
You have n.
We need U6. We need U6. So what's U1?
It's 2,500,000.
So I'll write it as 2.5 million.
Okay.
Times 1.02. What do I raise this to the power of?
5 because it's 1 less than u6.
So it's n minus 1, which gives us 5. put that into the calculator. What do we
Yes,
get?
us 2,760,000.
2.7.
60202. Would we get full marks if we just said 2.76 million?
Yeah.
Well, so since it's money, shouldn't we divide it to
I'll
this?
talk about that at the end.
2 times the ratio of that.
No, to the power of
Divided
to the power of. We need
Sum of numbers.
sum of 6 numbers. So what is U1?
It's 2.5.
2.5.
Parentheses, it's going to be 1.02 to the power of 6 minus 1. And then over 1.02 minus 1. Which equals 15 point.
Give me it to 2 decimal places first.
15.77.
15.77.
And 2.
No, let's go for the whole number.
Oh, 15.777.
So it's 15 million, did you say?
Yeah.
Point.
0.770 302.
The decimal place, he wants the decimal.
Well,
Yeah.
just let's counter this.
Can we get the next 2 digits?
Yeah, just you can just press it. All you have to do is press it. You don't have to go to the settings. Just press it.
No, but actually,
Can we get the last 2 digits?
4-1.
4-1?
Yeah, because it's 408.
That is the same number. No, it's the same one for the water sector.
I know that.
Oh, okay.
Wait, no, now. Oh, so do you only have to?
Now, I've done it to 2 decimal places because it's currency, and I've done it to 3 significant figures. Now, depending what you're using this information for, you could choose either of these 2. So which of those 2 would I choose to use if I was giving Kenza's parents the bill?
The 2 decimal.
You round it because 15.8. It's higher.
No.
No, it's really too.
No, if you give someone a bill, you want the exact bill. So you
Oh, I thought you were trying to like get more money. Oh, okay.
Yeah.
Never mind.
If you're going to give them the bill, you want the currency one. Now, if I'm talking to my friend and they're like, how much do you pay in school fees for the 6 years? Which one would you use there?
15.8.
See how the 2 make sense in different situations. If you're telling your friends how much it costs and you tell them that
It's 15 million.
that 10-digit number, they'll think you're autistic or something. But if you tell them, oh, it's about 15.8 million, that's what you might say if you're just sort of expressing this and having a conversation with somebody. So the 2 types, math isn't scary. Math's supposed to make sense for different purposes.
No, it's still scary. Sorry.
It's still scary.
Honestly, really love this topic.
Okay.
Very fun.
All right. Number 3.
This one's fine. I like this.
Have a go at this one.
One more.
Have a go at number 3. Let's make it less sweat.
If you just say,
So it's like when you're talking, it's so nothing bigger. Some listening. Maybe I can
Caused by the use of
read it.
common.
24. All the terms are positive. We don't know how. So the first time
Yeah.
it goes on for an hour and a half. By the first step,
But it's hard. It's 6.
First. all the terms are positive. So common ratio
How many more slides are
2.
This is it.
First term
there?
equals
So after this, genau so machen.
easy balance.
Sorry, let's pull. Here we go. So our last one. The second term in the geometric sequence is 6. So let's write this one up. We've got U1, sorry, no. We've got U2 equals 6. We've got U,
Sorry.
That's
if we wish to calculate U4 and we're at U2, how many lots of R do we have to multiply by? 2. So look, U1, U2, U3, U4. To go from here to here, we times by R, we times by R. So count along your, how many places along your sequence do you have to move? And that is how many lots of R will get you from one to the other. So that then means we've got 24 is equal to 6 times R squared, which means, so I'll do it like this, 24 divided by 6 is R squared.
Which means
So
4 equals R squared.
4 equals R squared.
Meaning R equals 2.
R equals 2. Why doesn't it equal plus and minus 2?
That's because all terms are positive. It's given to us in the question.
If it didn't say this, we would have 2 answers, but it does, so we only get 1.
Yes.
Thank God.
That means we can find U1 by dividing U2 by 2.
So, yeah, we could find U1 in a few different ways. One technique would be to take U2 and divide it by an R.
Give us 6 over 2, which equals 3.
6 over 2, which equals 3. And that gets us U1, and that's everything for A. B, we need to find the sum.
Yes.
So we need the sum of,
Sum of 10.
sum of 10 terms?
Yes.
We need the sum of 10 terms.
So that's
So U1,
which is 3.
3.
Parentheses 2 to the power of 10. That's the numbers, and then minus 1. And over 2 minus 1, because that's the combination. And that gives us 3069.
Gives us 3 times 10 to the 24 minus 1 over 1, which is 3 times 10 to 23, which is 3069. That is it for geometric and arithmetic sequences and series. We shall have a quiz on this next class.
We haven't written this in segment notation yet.
We don't have.
We don't have to.
We don't have it in the class?
So, segment.
So wait.
So segment